Hi, welcome back to Engineering Drawing. I am your Dr. Vasu. Hope you are enjoying the videos on engineering drawing. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create more such videos in the future. Now let's see the conic sections in this today. What are conic sections? So conic sections means when a cone is, we know the cone, when a cone is cut in different positions, we get different shapes. They are ellipse, parabola, and hyperbola. Let us see how we get this. Suppose you take a cone, when you see it in one view, front view, it appears like a triangle-like. But when it is cut here by a line, right? If you take a knife and just cut it like this at an angle to the axis or to the base like this, intersecting all the generators, right? All these lines which here on the surface of this cone are called generators. All the generators are cut. Here you get a section plane is cutting all the generators. Then you get a shape like this. This shape is called an ellipse. Okay, this shape we call it as an ellipse. Suppose you take the same cone and cut with a section plane, that is just to take a knife and parallel to one of this end generator, like this, and you get a shape like this, right? It's an open curve. In this case, it's a closed curve. It's an open curve here, and we call this as a parabola. This shape, we call it as parabola. Suppose we take the cone here and we cut it perpendicular to the base like this, okay? Or in some other angle, not parallel to, right? Not parallel to the end generator, we get a different shape like this. That is called a hyperbola. That shape we call it as a hyperbola, and this is also an open curve. Let us see how to construct these conic sections. Because we are cutting this a cone, we are getting these shapes by cutting a cone. We call them as conic sections. So let us see. And coming to this, these curves are differentiated with the help of a parameter called eccentricity. When the eccentricity is less than 1, we call it as ellipse. When it is equal to 1, parabola. Greater than 1, hyperbola. Let us start with an ellipse, right? And coming to this ellipse, let us see how the ellipse is and what are its characteristics. Generally, we have, for an ellipse, we have a major axis and minor axis, right? And suppose you take a line and intersecting this here, you got this is a, suppose this AB is the major axis and CD is the minor axis, and these two are intersecting here at a point called O. And suppose we have we call this AB as major, CD as minor axis. So you are given the curve, suppose. Now coming to the characteristics of this one, it has two fixed points called focus points, foci. 2 points, F1 and F2. They are foci here. And suppose if I take some point on the curve, anyway, on the curve here, some point P, and if I join this point P with the focus F1 and F2, right? Pf1 and Pf2, the sum of these two is equal to the major axis AB. Okay. You take any point, suppose some other point here, Q. You join with the F1 and F2, the QF1 plus QF2 is again AB. Any point on this satisfies this condition, then only we call it as an ellipse. Okay. So here, suppose if you take a CF1, right? CF1 and CF2. These are both are equidistant points. The point C is equidistant points, and that is equal to AB by 2, half of this one, that is AO. Okay, we can make use of this one to make use of it. Let us see. We have seen that, right? In this, we have seen CF1 plus CF2 are two equidistant. The point C is at equidistant from F1 and F2. And CF1 plus CF2 is equal to AB by 2, that is half of AB, nothing but AO. Let us make use of this one and let us find the focus points, right? Initially, suppose we are given the curve and you want to find out the foci. How? Take the AO length, right? Half of this major axis. Some point C as center, you cut this, you get a point F1. And here you cut this, you get another point, that is F2 joint. So because of this, CF1 and CF2 are equal and each one is equal to half of the major axis, we can use it to find the foci. Okay, that's. Suppose you are given the ellipse and you want to draw some tangent anywhere on this curve, right? We want to draw a tangent, some point here. Suppose I have taken a point and call it as P. To find the tangent and normal, you join this point P with the F1 and P with F2. You get some line, some angle here, F1, P, F2. Bisect this angle here like this, and you get the normal, draw a perpendicular at point P, that is the tangent. So like this, you can get the tangent and normal for the curve. Now, suppose the eccentricity of 2 by 3 is given, and the focus is at a distance of 50 mm from the directrix, and you are asked to draw the curve ellipse. Let us see how. Draw a horizontal line, and that is called the axis. Draw some perpendicular line to this. We call it as a directrix, and say I call it as AB, and this intersection point we call it as C. Mark 50 mm distance here on this 50 mm distance of that is the focus points. The focus F1 is at this distance. So at 50 mm we have marked the point here, and that is called F1. So CF1 is 50 now. So here, because the eccentricity is 2 by 3, let us do one thing. 2 plus 3, 5, right? So let's divide this into 5 equal parts. CF1 into 5, 1, 2, 3, 4, 5 parts. Okay. Now from F1, you take the second point, right? You take the second 2 here. So you take the second point and mark it as V. We may call it as vertex or something like it. Say point V. Now at V, you draw a line, perpendicular line here, and with VF1 as radius, draw an arc. This intersects here at some point. Through C, join this point here and extend. Okay. Now this point you may call it as E. So CE is joined and extended. Now here we are ready to draw the curve. How? Beyond V, you take some points on this line axis. Say I've taken some point somewhere. It's need not be at a fixed distance or anything. Any point you take. Suppose I call it as some point here, right? And this point I am calling it as 1. Draw a vertical line here. This intersects this extended line at a point 1 dash. Now, okay. Now 1 dash as radius, F1 as center. You draw an arc intersecting this line, vertical line, 1 dash, this line. Okay, I get a point here. This is a 1 dash length. So I get a point P1 here. Similarly, with the same radius, that is 1 dash as radius, from F1, we have drawn a point in the top. Draw another arc in the bottom intersecting the same line, right? We get another point that is called P1 dash. Corresponding to P1, we have another point in the bottom, P1 dash. Like this, you get many number of points here on this axis. You get many number of points and follow the same procedure and you get a number of points here on this. So let's see. We have taken another point here. I call it as 2 and drawn a 2 here, drawn a vertical line intersecting here at this line at 2 dash. 2 dash as radius, F1 as center, draw an arc and this is intersecting here and they call it as P2. With the same radius, intersect this in the bottom, right? The same radius, call it as P2 dash. Now another point 3 here we have taken, right? So 3 dash, right? 3 dash as radius, F1 as center, intersect this line, 3 dash line, right? This line. And here also that is P3. Intersect in the bottom also, you get a P3 dash. Like this, you take 4.4 here, 4 dash as radius, F1 as center, intersect this. And here also in the bottom, you get another point, P2 dash, P4 dash. Like this, you get as many number of points as possible. Join all these points by a smooth freehand curve, right? Smooth freehand curve like this. And if you extend, when you get a number of points here also, right? You get this closed curve called ellipse. Okay. Now we can extend the same principle. This one on the right side, you mark this point as a V, you call it as V dash. Okay. And at the same distance, right? From V, we are at this 2 points distance, right? 1, 2. At this distance, you mark F2 here, right? We got F1. We mark F2 here. And if you mark 3 points on the right side, you get another point C dash corresponding to this C. And you get the corresponding to this directrix, you get another line here, A dash and B dash. So here, this is on the right side. But this is not important. You need not even draw on the drawing sheet. The curve is important. Once you complete this curve, that will be sufficient and name the curve as ellipse. Okay. Now, suppose you are given the curve using the previous method. You have drawn the curve. And now we want to draw the tangent and a normal to this ellipse. How? Right? You take some point here, P, some point P. Join this point P with the F1. Okay, point P with the F1. Draw a perpendicular line to this, which is extended and it intersecting this directrix at some point, say T. Join this point T with P, right? That is the tangent to the curve, tangent to the ellipse. At this point P, now draw a perpendicular to this line, right? This is the tangent. Perpendicular to this line passing through P, you get the normal. So like this, we get a tangent and normal for this curve. Once you have completed drawing, you can draw the tangent and normal also like this. Okay. Hope you understood this topic very well. And if you have any queries or doubts or any suggestions, please do comment in the below. Right? Thank you very much. In the next video, we are going to see other methods of drawing the ellipse.